Hello, in this video, let's talk about the fundamental theorem of algebra. Fundamental theorem of algebra. This is one of the very key theorems that we have, and that's why it's called the fundamental theorem. And what it does is it promises us it promises to tell us how many solutions any polynomial will have. So what this theorem says is that the number of solutions, that means the x intersects any polynomial has, is equal to its degree. And the degree is the highest power or the highest exponent of that polynomial. Now, the thing is that when we use the fundamental theorem of algebra, we must include all the answers, including multiples and imaginary. So let's look at an example. Let's say we have a polynomial, and let's say this is y equals x to the third minus 3x to the 2 minus x plus 3. Now, this is a polynomial, and the highest power, the degree, is equal to 3, which means when we look at a sketch, we will expect to see 3 x intersects. So let's have a look. Now here is the calculator, and let's type in the equation: x to the third, x to the power 3, and then minus 3x to the 2 minus x plus 3, and here's the graph. And we can see that we have 3 x intersects: 1, 2, 3. And we can even use the calculator to tell us what those are. But that's what the fundamental theorem of algebra promises. It promises to find, it doesn't promise us to find what those intersects are, but it does promise us to identify that there will be 3 solutions. Now, here is another example. Y is x to the 2 plus 1. If we make a sketch of it, it's going to be a parabola that is hanging 1 unit above the x-axis. Now, the fundamental theorem of algebra will promise us 2 solutions, or 2 x-intersects, and yet there are no x-intersects on that picture. And the reason is that both of those solutions are imaginary. And so in this example, we have 2 imaginary solutions. Just like fundamental theorem of algebra promised, the number of solutions will be equal to the degree, but we have to include the imaginary, and the imaginary answers will not be seen on the picture. Another situation that could happen is we could get the same solution more than once. So here is an example. Y is x to the 4th minus 6x to the 3rd plus 5x to the 2 plus 24x minus 36. This is a polynomial. Fundamental theorem of algebra will promise us 4 solutions if we count the repeats and if we count the imaginary answers. So let's look at the calculator once again. And so here is the graph. let's type in the equation. X to the power 4 and then minus 6x to the power 3 and then plus 5x to the 2 plus 24x minus 36. So here is the picture of that equation. And there is one intersect. So looking at the diagram, we see 1, 2, 3. The solution the theorem promised us 4 solutions, but we only seen 3. How come? And if we were to look at this diagram closer, it would come up like this, and then make a comeback, cross, and then bounce back. So graphically, when we look at this sketch, that's a very poor sketch, but graphically, when we look at it, each time our graph crosses the x-intersect, that means, so if the graph crosses the x-axis, that means we have odd multiplicity of this solution. Meaning that this point could happen once or 3 times or 5 times. Same with this, it could be once, 3 times, 5 times. But if the graph bounces, like here, if the graph bounces off the x-axis, then we have even multiplicity of solution. So this could happen, this point could happen 2 times, 4 times, 6 times, any even number. So since we have 4 solutions, what really happened is we have this point once, this point once, and this point twice, 1, 1, and 2, that's a total of 4 solutions. And we'll discuss how to find these numbers in a different video note, but this is just what the Fundamental Theorem of Algebra can do for us. So as we're making a sketch of all of these things by hand, we will be asked to find the x-intersects, and the Fundamental Theorem of Algebra is absolutely key for knowing how many x-intersects there should be total in the question. And that's what the Fundamental Theorem of Algebra does. And that's it for this note. Thanks a lot for your time. Take care.